students. Now we will discuss about the pin diagram of 8086 microprocessor. As we know that 8086 is a 40 pin IC similar to 8085, and it operates on three different frequencies of 5 MHz, 8 MHz and 10 MHz. It can be operated in two different modes, minimum mode and maximum mode. What is minimum mode? What is maximum mode? Minimum mode is used when microprocessor has to operate for a small system where single processor is required, and maximum mode is used when microprocessor is used in large systems where multiple processors needs to be connected. The signals or pins of 8086 can be categorized in three different groups according to their modes. Some pins or some signals can be used for both in both minimum and maximum mode. Some pins can be used in only minimum mode, and some pins can be used only in maximum mode. So we will discuss one by one about each category. These are the categories of these are the categories. First category is of signals having common functions for both maximum and minimum mode. Second is signals having special functions for minimum mode, and third is signals having special functions for maximum mode. In common mode, these are the signals which can be used. First is AD0 to AD15. AD0 to AD15 is multiplex address object data lines. In first machine cycle, these lines are used as address bus, and after that it can be used as data bus. It is quite similar to 8085. Second is A19 oblique S6 to A16 oblique S3. These signals are address oblique status signals. In the first machine cycle, A19 to A16 signals are used as address signals, and after that, in subsequent machine cycles, these are used as status signals. Third is BHE oblique S7. It is also called bus high enable oblique S7 pin. It is at pin number 34. It is at pin number 34. Bus high enable pin signal is similar to a signal ALE, address latch enable, in 8085. When the signal at this pin is high, then buses AD0 to AD15 are used as address bus, and after when it becomes low, these buses are used as data bus. In the first machine cycle, this pin number 34 is used as BHE pin, and after that, next machine cycle, this is used as a status signal S7. Next is pin number 17, that is NMI. NMI is non-maskable interrupt. It is a level triggered pin. It means that it responds to the signal. It is positive as triggered pin. It is positive as triggered pin. It means that it responds to a signal which is positive going. When the signal is positive going, signal has positive edge, then an NMI, that is non-maskable interrupt, will be processed, and if it is at negative edge, then that interrupt will not be processed. Next is INTR, that is interrupt request pin. It is at pin number 18, and it is level trigger maskable interrupt. This pin or this signal is a level triggered maskable interrupt. As we know that signals are of two types, as triggered and level triggered. So some signals are as triggered, they response to the transition of signal from positive to negative or negative to positive. If the signal is positive as triggered, then the transition will be from low to high, and if it is negative as triggered, then the transition will be from high to low. And some signals are level triggered. Some signals are level triggered. It means either positive, that is 1, or negative, that is 0. Next pin is clock pin, which is at pin number 19, and this is used to give the clock signal, connect a clock signal to the microprocessor. We know that microprocessor 8086 operate at 3 different frequencies, so that this clock signal, that is a square wave, can be given through this pin. Next is reset pin at pin number 21, and it can be used to reset different registers like program status word, segment registers, and instruction queue of 8086. Next is ready pin. It is used for the synchronization of microprocessor with the peripheral devices, and when a microprocessor with the peripheral device, when the signal on this pin is low, then microprocessor has to operate in wait state. Test bar pin. This pin will be used in the wait condition of the microprocessor. Next is read bar, that is at pin number 32. It is output pin. This pin is used when microprocessor has to take data from any memory or IO device. Next is MN/MX bar, that is minimum/maximum mode. It is at pin number 33, and this pin is used to differentiate microprocessor operation is in minimum mode or in maximum mode. When the signal on this pin is high, then microprocessor operate in minimum mode, and when the signal is low, then it will operate in maximum mode. Second category of signals are those signals which are especially for minimum mode of operation. Here, these are the signals. At pin number 24, there is a signal called INTA bar, that is interrupt acknowledge. It is active low signal, and it is used to acknowledge the receipt of unmaskable interrupt, that is INTR. Next is at pin number 25, address/enable pin. This pin is used to demultiplex address/data pins 80 to 8015. When the signal on this pin is high, then that multiplexed buses 80 to 8015 are used as address buses, and when the signal become low, these buses will be used as data bus. Next is DEN bar at pin number 26. That is data enable signal, and it is active low signal. So when the signal on this pin is 0, then microprocessor is ready for the transfer of data with the peripheral, and when the signal at this pin is high, then microprocessor is not in the condition to transfer of data with the peripheral. Next is at pin number 27, DT/R bar, that is data transmit/receive mode. When the signal on this pin is high, then the microprocessor sends the data, and when the signal is low, then the microprocessor 8086 receives the data. Next is memory/IO bar, pin number 28. This pin is used to differentiate memory or IO operation. When the signal on this pin is high, then microprocessor interact with the memory peripheral, and when the signal is low, then it will interact with the IO. Next is WR bar, that is write bar. It is active low signal, and it is used to give the data from the microprocessor to the peripheral. Last two pins are hold and HLDA pins. These pins are used for the hold pin is used by the peripheral device to request the control of buses, and HLDA pin is used to acknowledge that request. Hold request will be from the peripheral to the microprocessor, and HLDA is the acknowledgement signal given from the microprocessor to the peripheral. In place of HLDA and hold, in the maximum mode of operation, there are pins RQ/GT1 bar, RQ bar/GT1 bar, and RQ bar/GT0 bar, that is request/grant signals. These are active low signals at pin number 30 and 31, and these are used to for processing request and granting the control of buses to the peripheral. Apart from these signals, some other signals are in maximum mode of operation, are QS1/QS0 bar, S2, S1 and S0 and log bar. Log bar is the signal at pin number 29, and when the signal at this pin is low, then my data bus of the microprocessor is in lock condition, is not available for any other device to use it. Now we will talk about these two signals, that is QS1 and QS1 bar and QS0 bar, and S2, S1 and S0. QS1 oblique QS0, QS1 and QS0. These are the we will show a table through which we can explain the operation of QS1 oblique QS0 bar. These are the active low signals, and these can be used to show the operations which can be performed by the instruction queue. These pins or these signals are used to show the operations that are performed by the instruction queue, and that operation will be dependent on the values of QS1 and QS0 bar. This is the table which shows the different operations performed by instruction queue when the signal on both the pins QS1 and QS0 is low. Then no operation will be performed and Q will be in idle state. When the signal is 0, 1, that is QS1 is 0 and QS0 is 1, then first byte of an opcode of an instruction queue is fetched. When it is 1, 0, then instruction queue is in empty condition, and when it is 1, 1, then subsequent byte of an instruction queue will be fetched. So we know that in 8086 the data bus is of 16-bit. That 16-bit data bus is used to fetch the opcode from the memory. So if the opcode is of 8-bit, then in one cycle data bus is able to take two opcodes simultaneously. So the values of QS1 and QS0 controls the placing of these opcodes in the instruction queue. When it is 0, 1, then the first opcode or first byte of the opcode from the data bus will be placed in the instruction queue, and when it becomes 1, 1, then the subsequent byte of data bus will be placed in the instruction queue. Next is S2, S1 and S0. These pins are at pin number 27, 28, 27 and 26. These are the output signals and used to show output status signals, used to identify the different types of operations related to data transfer operation. Like data transfer is between memory and microprocessor, or from IO to microprocessor, or inside the microprocessor. So when the values on this pin is 0, 0, 0, then the function of microprocessor is to interrupt acknowledge, that is acknowledging an interrupt. When it becomes 0, 0, 1, then IO read operation will be performed. When it is 0, 1, 0, then IO write operation will be performed. In the case of 0, 1, 1, microprocessor will be in halt state. In case of 1, 0, 0, instruction fetch operation will be performed. In case of 1, 0, 1, memory read, and in case of 1, 1, 0, memory write operation will be performed. When the signals on these frequencies are high, then this is undefined condition and there is no operation performed. So these are the different pins in different operating modes of the 8086 microprocessor. Students, related to pin diagram of 8086, questions will always be asked in the university exams, and these questions will be of long answer type. Therefore, you have to write at least one line about the each pin in the three categories. Thank you.